Look above, there's a sticky note which should indicate which grade justice. Please look above, look above. There's a sticky note there. There's a red cup. I don't know what you would call that, but there's a yellow background with a message there. It says Showtime, grade 11. So we are with the grade 11s. Grade 11s, welcome to the live session for your maths. We are continuing on as per the annual teaching plan. Last time we met, which was yesterday night, we rehashed on the process. Your network. Okay, let's just confirm network before I even start. Seems like the network is not networking. I just want to check again. Please confirm, people, the normal peoples. Queen is saying the network is very bad. Sweet is also saying the network is not so sweet. Yeah. Okay. Then give me a sec. Give me a sec. Lonze, you're always full of generosity. Thank you so much. Lonze, you're always full of generosity. Thank you so much. Even in my absence, thank you so much for the ice cream, the nice ice creams. The network is baiting. These people, network is baiting. All right, so let's just check again. Let's check again if the network is still betting. If the network is still betting, then I guess it's betting day to day, and therefore it must mean that we most probably must say goodbye to the session today. Any indication of network being better, even if it's just slightly better? Okay, Tlotlego has thumbs up. I just need to get an indication if there are other people that are saying the network is slightly better. If it's not, then Justice only cares about the grade 8s. Oh man. Yeah, he's on the grade 8, that's for sure. And maybe Justice, what you can do, motivate. Maybe you can send me a message. I'll sleep on it. You can send me a message just on my TikTok inbox and let me know why you feel so strongly that I should kickstart the grade 8 sessions, and then we'll take it from there. For now, I'm with the grade 11s, and I need to just check if the grade 11s are here with me. All right, 10:30, we'll continue with the grade 12s. So grade 11s now, grade 12s later. So all my grade 11s in the Hizzles in the house, welcome to you. Those who have not been here, maybe because of reasons that they know, we have been kubaring, we have been chai saring, we've been we've been pushing, and we, for the past 2 sessions, we've been doing completing the square of a quadratic expression. It's pure maths, sweetie. What a name you have, sweetie. Yeah. Some people on TikTok, they really go the mile and the extra mile in these TikTok names. Pure maths. So, like I was saying, we did a quadratic expression, how to complete the square of a quadratic expression, how to find the maximum or the minimum value. In fact, being able to know if it's the minimum or the maximum that we want. Then secondly, how to identify the maximum or the minimum from a given quadratic expression after we have completed the square of that expression. And then lastly, how to be able to identify the value of x which gives us the minimum or the maximum. So for my good people that have missed out on those sessions, my plea to you is go to my YouTube channel and watch the 2 sessions I've posted up. The day before yesterday, I started quadratic expressions, how to complete the square of a quadratic expression, and then I gave people some work to do at the conclusion of the session. When I came back yesterday, it was very clear to me that there were still challenges. Okay, there were still challenges, so I redid sort of like 2 problems to sort of explain the concept again. The name of the YouTube channel is called Maths is a Game. Okay, it's called Maths is a Game. You can go to my bio. There's a link there on my bio. Maths is a Game. You can just click on it. It will send you directly to the YouTube channel. Then on there, the 2 most recently posted videos are one video of the grade 11 session for quadratic expression, which is the one that I did yesterday. It currently does not have a thumbnail that is characteristic of the other thumbnails of all the other videos, because I've not designed the thumbnail yet. So it's just as raw as you can possibly get it. You can go there, check it out, and watch the live session. Then there's the live session I did before yesterday, which was the introduction of completing the square of the quadratic expression. Yesterday, I sort of explained or re-explained how to complete the square of a quadratic expression, due to the fact that I could see that some were still struggling or still had a challenge on how to complete the square of an expression. I unfortunately will not today continue doing the completing the square of a quadratic expression. Today I am continuing on with my program of quadratic equations. So I am going to step into the solving of quadratic equations, which is not something new for a grade 11 learner. It's very old. It's old news. You began solving a quadratic equation in grade 9. That's where you began solving a quadratic equation under caps. Then in grade 10, you did it again. Now in grade 11, we are simply revising a concept that you already know and making sure that you know it very well, so that we can move on to other things that pertain to a quadratic equation. Yes, women of faith, this session will be on YouTube, right? Yes, indeed. So let's go, guys, and look at the quadratic equation session that we have today. So today we are going to look at quadratic equations. Remember, yesterday we did not look at quadratic equation. We looked at a quadratic expression. And then I also mentioned yesterday that we need to distinguish between what a quadratic expression is and what a quadratic equation is. There's a difference. Once we note the difference, then we will know how to deal or delve into a specific problem. Queen is crying about my network, but my network says my connection is very good. So I think, Queen, it is you, not me. You know, it is you. It's not me. The problem is not with me. It is with you. Yeah, so I think situation is on your side. I cannot be blamed this time round. I know that at the beginning, it was my fault. So I left you guys momentarily so that I could go fix my situation. Now I came back, and when I see my little green dot there, it says good connection. So I know the problem is not with me. So Queen, sort it out from your side, Nkosazana, please. So we're going to look at quadratic equations. Specifically, I want us to delve into this thing. This SF that I have here stands for standard form. Standard form. A quadratic equation has this standard form: ax squared plus bx plus c. If this equal to 0 was not there, then we would talk about this being a what? A quadratic expression. But the moment we have something on the other side of the equal sign, we no longer talk about a quadratic expression, but we are talking about a quadratic equation. So there is a distinction between what an expression is and what an equation is. So ax squared plus bx plus c, without the equal to 0, if that was not there, simply terms, we say that this is an expression. But if we have equal to 0 on the other side, then this is a quadratic equation. Boitumelo is asking me, what's the topic? We are now delving into equations and inequalities. So if you look at your ATP, after exponents and surds, you jump into what? Equations and inequalities. Where it starts is where you start with what we did the past 2 days. Currently, we are where now we are supposed to deal with quadratic equations, specifically solving a quadratic equation. Are you with me? So I'm still looking at the concept of what a quadratic equation is, all right? And please, people, all right, what I'm saying is, I don't know what part you want me to repeat. RMJ MEBS 27. You want me to repeat which part? All right. Okay, so once again, we are dealing with quadratic equations. And what I was saying is that a quadratic equation has what we refer to as a standard form of the equation. The standard form of the equation is ax squared plus bx plus c is equal to 0. This is what we refer to as a what? A quadratic equation. Why? Because a quadratic equation has a characteristic x squared term followed by an x term followed by a constant term. This a and this b and this c are what we refer to as any real number. These are variables that stand for any real number. Real numbers are basically all the numbers in the number system. So A, B, C can be any real number in the number system, right? But a quadratic equation will have an x squared term, a x term, and a constant term. This form that you have here of this equation is what we refer to as the standard form of the quadratic equation. So very important. I hope you've noted that. Why quadratic? Is it from the characteristic of the equation or expression given? Remember, the word quadratic simply means a expression. The word quadratic simply means an expression that has as its highest exponent 2 for the variable x. An expression that has as its highest exponent or its highest degree the exponent 2. That's what quadratic stands for. Okay. So quadratic expression is any expression that has as its highest degree or exponent 2. All right. That's what quadratic stands for. And then what I'm saying is that this here, ax squared plus bx plus c, if there was no equal to 0 and we just said ax squared plus bx plus c, we would refer to that as a quadratic expression. But seeing as though there's ax squared plus bx plus c and then we have an equal and there's something on the other side, we refer to this as a quadratic equation. An equation has a left-hand side and has a right-hand side. That's what an equation is. But an expression does not possess another side. It simply is a expression of terms. That's what it is. All right, now I'm going to move on. I think I've exhausted the meaning of quadratic equation. The next thing, we can solve a quadratic equation. We can solve a quadratic equation. It can be solved. And you know what? The solutions of that particular equation, that quadratic equation, we refer to them, or they are called the roots. They are called the what? They are called the roots. The solutions of a quadratic equation are called the roots. So those solutions that you get, those values of x that you get at the end, we call them roots, okay, of the what? Of the equation. So this is an important thing here. That's another concept here that you need to take and hold very dear to your heart. That all these solutions that you get at the end, they are called roots, okay. Now, there are 3 methods that we can use to solve a quadratic equation. 3 methods. And today we are going to look at one of the methods. One that you are already familiar with, that you've been doing since grade 9. That particular method that I'm referring to is called the factorization method. Now, just for your information, the 2 additional methods that are there to solve for a quadratic equation. The second method is called the completing the square method. So even in the quadratic equation, we can actually solve for x by what? By completing the square of that equation. We are going to look at that later, not now and not today. Then there's a third method. The third method is called the quadratic formula method. There's a specific formula that we can utilize to solve for any quadratic equation. This formula or this method, this formula that we use is called the quadratic formula, and so we call the method itself the quadratic formula method. Are you with me, people? I hope to. So far we are going together. We are all together. So just to recap, what have we said so far? Hello, Kat. By the mere fact that you're asking, can you join? You're already here, so I'm guessing you have joined already. Right? Yeah. So here we are. Quadratic equations for grade 11. I am saying, what is a quadratic equation? Simply put, a quadratic equation is an equation that basically possesses as its highest exponent for the variable x the exponent 2. In other words, the degree of that expression is 2 because the x variable, its highest exponent is 2. That's what qualifies an equation as quadratic. So, generally speaking, the standard form of a quadratic equation is ax squared plus bx plus c. And then the equal to 0 is to just also make us understand that this is not just any type of thing, it's an equation, because there's a left-hand side, and on the other side of the equal side we have a right-hand side. So this is really an equation. But what type of equation? It is a quadratic equation. Why quadratic? Because the expression on the left-hand side has as its highest exponent for x 2. That's what qualifies this as a quadratic equation. This is what we refer to. Ax squared plus bx plus c is equal to 0. We refer to this as the standard form of a quadratic equation, where a, b, and c can be any real number. Then, the next thing, the solutions. When we solve a quadratic equation, because it can be solved, the solutions of an equation that is quadratic are called the roots. R-O-O-T-S. I'm not talking about the tap roots and adventitious roots that you learned in life science. No, I'm not talking about that. I'm talking about the roots of a quadratic equation in mathematics. The solutions of an equation are called the roots of the equation, the quadratic equation. Okay? Now, to find these roots, there are 3 methods which we can use to what? To solve an quadratic equation. Are you with me? These 3 methods are simply one. The first method, we call it the factorization method. You guys have been using the factorization method since grade what? Grade 9. So by now you should be masters. All of you who are here in the call, you should be masters at using the factorization method. The second method is called the completing the square method. This is a method that you are learning for the first time in grade 11 if you are a new grade 11 learner. The completing the square method, how to solve an equation using the completing the square method. We will delve into it and look at the specifics when we get to that method. Then the third method is called the quadratic formula method. It is a famous method that is loved by many. You go to any grade 12 learner, the minute you give them a quadratic equation and you ask them to solve for that quadratic equation, any grade 12 learner who's been through grade 11 loves this method. And they even, will say a lot of things about how much they passionately love this method. It's like they love this method more than they love anything else in the world. All right. So let us continue. Thank you, Precious, for the heart me. You are hurting me. You are showing me love. Really appreciate that. Now let us proceed, guys, and just look at a few examples where we can utilize this factorization method just to bring our memory back, because it's not like we don't know how to use this method. We know this method. We are good at it. We are masters at it. We are great people at it. But let us take note of a few things. And I want to suggest that even in the factorization method, there are practical steps that any learner should be able to utilize in the factorization method in order to ensure that when they use this method, they are able to show all the appropriate steps and be able to afford themselves all of the marks that are required. Because I know you guys are all about marks, right? So our first equation, I know you love this one, guys. You can see you see all the people grabbing their pens even before I even grab mine, and they are already telling me the answer in their heads and all of that stuff. So let's look at this. So the question says solve for x. This is what you guys have for breakfast, lunch, and supper every day in your heads in mathematics. Everybody in this call knows how to solve this thing, all right? But may I suggest that in your head, as you know already how to solve it, please take note of what we need to ensure takes place as we solve an equation of this nature. If we are using the factorization method. we are inundated with practice of this method because, like I said, from grade 9 you've been using it. Grade 10 last year you were using it. End of the year final exam you used it in your paper 1. So now you should all be saying that, Suka, say, why are you even wasting our time? This thing is easy. Okay, that's why even Star G, you can see in the comment section, Star G is like, is this for grade 9s? Because maybe even Star G is aware that, man, this looks like a grade 9 problem. You see what I mean? But we're in grade 11, people. So people in grade 11, as you are in a grade 11 session, should be able to solve this problem. And Totleho is saying, sir, can we skip the factorization method? And I'm like, no, I'm not going to do that. All right. Totleho, you are more than welcome, like I said, to, if you feel like this is going to be a bore for you, please, guys, I don't take offense. I do know that some of us, we are at different levels of understanding and comprehension with certain things, but please allow me, for the purpose of being able to upload this in a channel somewhere for other people that may bump into this and they don't, maybe are not as confident or are not as affluent as everybody else, allow me to have this session and complete it. Okay. So I'm not going to move further. I'm just going to stick to this method, complete it, and then Vakala. Yeah. So here we are. So x squared minus 5x is equal to 6. This is for grade 11s. But a grade 10 learner who's here will also get benefit. A grade 9 learner who's just entered into grade 9 will only benefit about this later on in the year. Okay, so please, people, it's very key, this thing. So x squared minus 5x is equal to 6. At the moment, we can see that this is an equation. So we can solve it. But we need to first get this equation in what? Into the standard form. Into the standard form. This equation is not currently in standard form. Okay, so what we do is we rewrite this equation. This 6 is on the right side. We need to actually transpose, and the word is transpose. Or we can say we are using what we call the additive inverse. If you minus 6 here, using the additive inverse of 6, you subtract 6. What you do on the left, you do on the right. It means we'd have to subtract 6 on this side as well. That will leave us with 0 on the other side, but we'll be left with minus 6 on this side. Are you with me? But guys, very importantly here, we transpose the 6, it becomes negative 6 on the right hand side, on the left hand side. Then equal to 0 is there on the other side. Are you with me? This is what we refer to as standard form. So we need to always get the equation first into standard form. That is step number 1. Remember when I said that the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. The 0 must be there. No other number on the other side but 0 in order for us to say that the equation is in standard form. 0, 0, 0. And then ax squared term, the x term, and the constant term. So you can see this. The x squared term, the x term, and the constant term equal to 0. So step number 1, standard form. Step number 2, this is a trinomial quadratic expression. We can factorize it. How? By opening 2 brackets. This is a quadratic expression that can be factorized. Why? Because how do we factorize the quadratic expression? First and foremost, we find out what are the factors of 6. The factors of 6, which if we multiply together give us negative 6, but if we add them, they give us negative 5. All right. So first and foremost, the x squared term will be made by x and the x. X times x will give us x squared. Then we need the factors of 6. Okay, which if we multiply give us negative 6, but if we add them give us negative 5. What are those factors? Can someone tell me what are the factors of 6, which if I multiply give me negative 6, but if I add they give me negative 5? Okay, now I love the fact that many people are saying different things here. And this is exactly where I feel most people are making a lot of errors. So if we get back to the fundamental problem that we are seeing, people, please observe what you see in the comment section. You can see there are people that are saying -2 and -3, right? Let's get all of them in here. We have -6 and 1. Someone said -2 and 3. -6 and 1, -6 and 1, -2 and 3. You can see the answers in the comment section. They are varying and they are not all the same. Now here's the thing. Let's test all of these. Okay, these are the different options that I've seen in the comment section. So if the people are saying -2 and -3, let's check a few things. If I multiply -2 and -3, do I get that constant term? What's a negative times a negative? It's positive. What's 2 times 3? It's 6. Let's take this -2 and -3 and actually put them together. What's -2 minus 3? It gives me -5, which would mean my middle term, is it -5? So let me check a few things. Is my constant term +6? Let's check. Is my constant term +6 here? No, it isn't. Is my middle term -5? Yes, my middle term is -5. But does this combination of -2, -2 and -3 actually help me out in this situation? No, it doesn't. So -2 and -3 are out. Okay, I don't even consider them. Remember that the numbers that I choose as factors, when I multiply them, need to be -6. I need to get -6. When I add, I need to get the coefficient of x. Are you with me? So let's look at the other option. They also wrote -2 and +3. Let's check. When we multiply -2 and -3, what do we get? We get -6. Did we have -6 as our constant term? Yes. Let's take the -2 and the +3 and put them together. What's -2 plus 3? We get +1. Do we have a coefficient of x that is +1? No, we don't, guys. So that means the option of -2 and +3 is also out. Lastly, let's take -6 and +1. If we multiply those two, what do we get? We get -6. Do we have -6 as our constant term? Yes, we do. Then lastly, if we take -6 and add +1, what do we get? We get -5. Do we have a -5 as our coefficient of x? Yes. So the option of -6 and +1 is accurate. The option of -6 and +1 is the most correct factor option. And this is the thing that's making me feel or say to you guys, we cannot just jump this section and want to chase the other methods, but we are still making basic mistakes or simple errors of not choosing the correct factors. Remember, guys, we have had the privilege or the opportunity of doing this in grade 9. We did it again in grade 10. You know what they say most, the first time you may miss it, the second time you may miss it, but in Xhosa they usually say okwesithathu ngumnqakathi. In other words, that just simply means that the third time round it's a charm. Third time round you should definitely do it right. So at this stage, factorizing a trinomial shouldn't be an issue. But what are we seeing here? We are seeing people still respond in the comment section that the factors are other numbers, and that is a problem fundamentally for me. Okay. Also, think of this: in grade 8 and grade 9, you guys did highest common factor. You did, all sorts of things that have to do with factors. At this stage, guys, you should be identifying factors like it's nothing, and you should easily get these factors done. Okay, so like I said, x minus 6 and x plus 1. Let us check again. Negative 6 times positive 1, does it give us the constant term? Yes, it does. And then taking negative 6 and adding to 1, does it give us the middle term, the coefficient of the middle term? Negative 6 plus 1 does give us negative 5. So this is correct. Our factors are 100% correct. This is what we call the factor stage. So hoorah to those people that actually got the factors negative 6 and positive 1 100% correct. So step number 2, we write down the factors we factorize correctly. So we moved from standard form, getting the equation into standard form, to factorizing. The third step, we apply something that we refer to as the zero factor law. I repeat, the zero factor law. What is this law? This law simply says that, if I was to generally speak about it, if you have a product of two things equated to 0, I repeat, if you have a product of two factors equated to 0, what do we mean by product? It means multiply. Two factors, A and B. If you have a product of two factors multiplied together equated to 0, if A times B is equal to 0, then you take one of the factors you equated to 0, or you take the other factor you equated to 0. But this only applies when I have which number on the right side? 0. And if I have a product of factors. Doesn't apply in any other situation. If you have another number, let's say 7 here, and you have a product of factors, you cannot use this law. This law only applies when there's factors multiplied together and there's a 0 on the other side. If you make the mistake of applying this law where there is no 0, then you are, hey, I don't know what law you are applying, but there is no such law. This zero factor law only applies when there's a 0. That's why it's called the zero factor, two factors law. Or in other words, they usually say it's called the zero product rule. Okay, so we apply that now because we have the factor x minus 6 and it's multiplied with the factor x plus 1 and it's equal to what? To 0. So can we apply the zero factor law? Yes, let's apply it. X minus 6 is equal to 0, or x plus 1 is equal to 0. Then after we have applied the zero factor law, then the last step, we write down the what. What did we call the solutions of our quadratic equation? When I was explaining at the beginning, we call the solutions of a quadratic equation what? Let's see if people were listening to me earlier on. What do we call the solutions of a quadratic equation? We call them the what? Woman of faith, you are a woman of faith indeed. Siamo, Vizi, Abu, Queen. You guys truly listen. So yes, we write down the roots. So x minus 6, we just solve this linear equation. Minus 6, we transpose minus 6. When minus 6 crosses over Jordan, miracles happen. The sign changes. X is equal to 6, or x plus 1 is equal to 0 plus 1 transpose, miracles happen. We get x is equal to negative 1. The time, the day of miracles has come. So that is our roots. And you know what, guys? You could quickly just take 6, plug it into this, and just check if it satisfies the equation. 6, for instance, if you check here, 6 squared is 36. Minus 5 times 6 is 30. 36 minus 30, does it give us 6? Yes. So 6 is correct. 100% correct. Minus 1. If you take minus 1, you substitute it here. When you substitute the number, people, you substitute it in brackets. If you don't put it in brackets, you take minus 1, you substitute it here without the brackets, your calculator will give you a totally different answer. I promise you. Okay, so when we substitute something, we use brackets to substitute it. So minus 1 squared gives us positive 1. And then 5 times minus 1, the negative 5 times the negative 1 gives us positive 5. So it's like 1 plus 5. 1 plus 5, does it give us 6? 6? Yes, it does. So these roots are 100% perfect. They are on point. Now, I want to think of those people that would have gotten or written down these other roots. minus 2 and minus 3. I mean, they would have proceeded, right? Without really even thinking, they would have put in that minus 2 and that minus 3 inside the bracket, solved for x, gotten the answer, and then they would have just proceeded and not even checked. So please, people, we can always verify our answer. This is the beauty. You don't even have to say, teacher, can you come and check my work and mark me? You can verify. And if you find that the verification process does not happen, you can always then go back and check, which step did I go wrong in? Was it probably the standard form? When I was transposing the 6 over to the other side, did the sign change? Did I write the standard form correctly? Or 2, did I factorize incorrectly? Or 3, when I actually saw that the zero factor law applies, did I transpose the minus 6? Did it really change the sign? Because sometimes these are the simple errors we make. Okay. So in essence, what I'm saying is, these are the steps. Standard form, factors, zero factor law, then your roots. Hey, I don't know if anyone is hearing me here. Yo, jo. Okay, all right, okay, yeah. That's example 1. Let's get another example. Example 2. Okay, 2x squared is equal to 18. So if you look at this, 2x squared is equal to 18. First question, is this a quadratic equation? Well, we have a term that has x and the highest exponent is 2, so this is a quadratic equation. Is the quadratic equation in standard form? Well, the quadratic equation is definitely not in what? In standard form. So what then do? We write the equation first and foremost in standard form. And obviously here we have 2x squared minus 18. We don't have an x term. There is no x term. And because there is no x term, there just isn't any x term. All right. Then let's look at this. Can we factorize this? Yes, indeed. What type of factorization, or what do you observe? Very good, 10 Roche 47. There's a highest common factor. There is a highest common factor. What is that highest common factor? It is 2. What do we do with the highest common factor in a equation? Not an expression. What do we do with the highest common factor when we have an equation? We do this, guys. We divide by the highest common factor. We divide each term by the highest common factor. Right? Some people will take it out, but after you take it out, you divide by it. So if you know what the highest common factor is, you know it's 2, right? Because this is an equation, you can divide by the highest common factor as long as the highest common factor does not have a variable. I repeat, as long as the highest common factor does not have the x variable, you can divide by it. Hey guys, and I'm going to do an example very shortly so that I can emphasize or make my point very clear. We divide by a numerical value. But if there was an x attached to this numerical value, guys, we wouldn't waste our time and divide by that. Never. We wouldn't do it. Okay. So the highest common factor, because it is a numerical value, I'm going to take each term and divide by that highest common factor. Then what do I get? X squared minus 9 is equal to 0. Ooh, this is a standard form that seems very nice. I can see the expression x squared minus 9. What type of factorization is x squared minus 9? Okay, do you still remember grade 9 and grade 10? What type of factorization is x squared minus 9? Giving what? Dots. Thank you, gift. Dots. Do we all know what dots is? difference, there we go, for difference of two squares. Difference minus x squared is a perfect square, 9 is also a perfect square. So we open, as my good friend Ten Roche said, we open two brackets equated to 0. X squared, and then since this is a difference of two squares, we usually say there's a minus and a plus bracket, and then the square root of 9, 3 and 3. All right. Okay. Yeah, because when we FOIL this out, we fold this back, we get x squared minus 9. So when it's a difference of two squares, we take the square root of x squared, we get x and x, because x times x will give me back the x squared. Then the square root of 9 gives me 3 and 3. Then we'll have different signs for each bracket. As a standard rule, we'll have different signs for each bracket, because a negative times a positive gives me back the negative. Are you with me? And then obviously, when we multiply this out, the middle term will not exist, because there will be a subtraction of the x term completely, which gives us 0. So there's no middle term. Okay. So I hope that's clear. Difference of two squares. Okay. So from the standard form, now we have the factors. After the factors, we apply the zero factor law. Because there's a 0 and there's a product of factors, we can now say x minus 3 is equal to 0, or x plus 3 is equal to 0. Then after that, the zero factor law, we get the roots. X is equal to 3, or x is equal to negative 3. Done and dusted. Okay, done and dusted. So this thing of standard form, getting a quadratic equation to be in standard form, is something that is sort of like a standard rule that we utilize to basically work with a quadratic expression on the left to factorize it and then solve for the variable x. Are you with me? So, and please take note, like I said, we do, if there's a highest common factor, first and foremost, we divide by that highest common factor. We don't take it out, because this is an equation. Different story if it was an expression alone. Because when it's an expression, we take out a common factor, the highest common factor. But because it's an equation, if it is a numerical highest common factor that we have, it's a number highest common factor, then we can divide throughout. Okay, but we still remain it still retains the integrity of the equation in order for us to solve for the roots of that particular equation. So here, maybe slightly something different. We still did standard form first, and then there were two types of factorization, if you will, that we had to carry out. First, highest common factor, because we had a highest common factor numerical value, which we divide by. Then next, our standard form, we can see that there's factorization. We factorize it, applying difference of two squares, because this is a difference of two squares type expression on the left-hand side, which gives us this equation. And then we factorize it. We apply the zero factor law, because there's a 0 on this side. And then we get the roots. And I mean, you can take these roots, substitute them back into the original equation. You will see, you substitute using brackets, the answers will really resonate. It will be spot on, 100%. You got them correct. Let's go. I think so far we are going very nicely, and I'm sure people are feeling the vibe. Let's look at this question, guys. 2x squared is equal to 24x. The first question that I like asking, is this equation in standard form? So you see, now quadratic equation, you always need to do this thing of making sure first that the equation is in standard form. Is this a quadratic equation first and foremost? Yes, it is, because the x variable has the highest degree of the exponent, which is 2, and that is the highest degree. So yes, we transpose, meaning we take the 24x, which is positive from the left, we bring it to the left, from the right, we bring it to the left-hand side, and it changes sign when it crosses over Jordan. Then we have 2x squared minus 24x is equal to 0. Do we have a highest common factor? Yes, we do. What is the highest common factor? Let's start there. Do we have a highest common factor? We agree, yes we do. What is the highest common factor? VZ, VZ and Precious, 10th, Resh 40, Gift. Those are the people that are writing the right things. Okay, some people are not writing the right things. So I repeat, do we have a highest common factor? Yes, we do. What is the highest common factor? So between 2 and 24, the highest common factor is 2. Between x squared and x, the highest common factor is, remember, when we identify the highest common factor for common variables, we go for the common variable that has the lowest exponent. So therefore, that means the highest common factor fully is actually 2x. Please, people, not 2. If you say 2, then I want to cry. It's 2x, guys, right? Yeah, it's 2x. Now, look at the highest common factor. It does not only have a number, but it also has a variable. So that means I cannot divide by 2. Rather, I'm going to take out the 2x as a highest common factor. Very important, people. I'm going to take it out, the 2x as a highest common factor. All right. Then let's proceed. What's left inside the bracket? X for our first term. Because it's x times x that gives me back the x squared. The 2 is already there. Minus what? 2 times what gives me 24? Or what's 24 divided by 2? Does anyone know? And what will be the term, the last term in my bracket? Thank you very much. It will be 12. And that's equated to 0. Good people, listen to me. There is a reason why I decided not to divide by the 2x. Because the minute I have the variable there, we don't divide, good people. We don't divide. We don't divide. If our highest common factor is a variable, we don't divide. We avoid division by all means. If it's a numerical value that's the highest common factor alone, then we can divide by it. If it's just a number. If the highest common factor is a number, we can divide by it. But if it is a numerical value attached with a variable, that's the highest common factor, we don't divide by it. And I'm going to show you just now why we don't divide. Now that we are here, we have factorized. Remember, we had standard form. We are factorizing now. What is the next step after that? What is the next step after that? We can apply the zero factor law. Why? Because we have a product of what? Of 2 factors. Product of 2 factors. We can apply the zero factor law. Okay? So we say 2x is equal to 0. We write that alone. Or x minus 12 is equal to 0 alone. Are you with me? Are you with me, people? 2x is equal to 0 alone. X minus 12 is equal to 0 alone. Then we can solve these independently and get the values of x. Yeah, when we solve them independently, now look what we can do here at this stage. We can divide by the coefficient. Because the coefficient, has no bearing. We can divide by the coefficient because we want what? We want x. So we're going to get x is equal to what? 0. That's our first solution. Or our second solution, x, we transpose the negative 12. It becomes x is equal to 12. That's our second solution. So x is equal to 0 or x is equal to what? To 12. Now imagine the danger we would have fallen into had we decided here to identify the highest common factor and then divide by that highest common factor. If we had decided to divide by 2x both sides, what would have happened? We would have eliminated one of our solutions, which is x is equal to 0. I repeat, had we decided to divide by 2x, which is the highest common factor of the expression on the left, we would have eliminated one of our solutions, which is x is equal to 0, which would have been a big mistake to have made. So please listen to me and listen to me well when I say, if your highest common factor in a quadratic expression on the left is a number only, go ahead and divide the equation for all the terms by that highest common factor and simplify, factorize zero factor law, and then get the answer. Okay, because the x is not gone. But you good people, if your highest common factor has a variable in it, don't divide by that 2x. Don't divide by it. Take out the highest common factor with its variable. Then apply the zero factor law after factorizing. And then here in this place, solve for x. And in actual fact, when you solve for x, you know that at this point you are going to have to divide by the coefficient in order to get the value of x. I hope we are together here, people, so that you don't lose a solution. Many a times learners have actually taken out a highest common factor, or they've decided to just take the highest common factor and divide by it when the highest common factor clearly has a variable in it, which is your variable that you are also trying to solve for. You are trying to solve for x here. Now all of a sudden you are eliminating the very x you are trying to solve for. You are eliminating the very x that you are trying to solve for. I hope nobody has an x here in this call. Good people, these things they are very sensitive, these things. Hope we are not putting ourselves under such. I hope that grade 11, as we enter into this year, we want to have good results. It's very painful when you hear people talking about the other x's, not the roots, the x from maths. They want to talk about the other ones, and then those ones are the ones that basically help make them lose attention, and they don't know how to solve for x in maths because they are thinking about their x. It's a problem, that thing. So let's try by all means to stay focused. Let's control our emotions, our feelings. Let's be in peace. Let's be here. Let's be present fully. Let's not allow anything to distract us, Otherwise, distractions, they will distract you until you'll cry alone. And how painful it is to be so, you're entangled in things like this, Yeah. Anyways, let's continue. Hopefully we are together so far. We are feeling this thing. I want us to continue though. Let's look at another question. I'm obviously going to give you your own for work, but I just want to look at the full breadth and scope. So let's look at this one. Look at this question. Hello, Helen. Welcome. It's nice to see you there. X minus 8 into x plus 2 is equal to negative 16. All right. X minus 8 into x plus 2 is equal to negative 16. So we can see here we have a product of factors, x minus 8 into x plus 2. But it's equal to negative 16. Now, I know some people, they look at this and they're like, oh, we have a product of factors. It's equal to negative 16. How many people are thinking here, so can't we just take x minus 8 equated to negative 16? Or take x plus 2 and equate it to negative 16 and then solve for those equations? How many of you are thinking that? Anyone who was thinking that, maybe we can just do that, it's quick, very fast, and we can help us with the answer. Take this one, make it equal to negative 16. Take the first bracket, make it equal to negative 16. Take the second bracket, make it equal to negative 16. Thank you very much. Vizi, I love you. I can just tell you that. I love Vizi, the fact that Vizi is so vulnerable in telling me that they were thinking that. So imagine if I had decided to skip this factorization method and just jump into the other things. Then you see the simplicity of what we are covering now wouldn't have been grasped. Now listen to Daddy explain to you, Papa, Mr. Maths is a game, and help you understand and comprehend. So those people that thought that we can take this bracket, make it equal to negative 16, and take this bracket and make it equal to negative 16 and solve, this is a big misconception that we have. Where does this misconception come from? Let me go back to the previous problems. Do you remember this one? When we got to this stage, 2x into x minus 12. And then it was equal to what? Remember, it was equal to what, guys? It was equal to This is a number that's very important. It may hold to be nothing, but it's equal to what? Can I know this thing? What's this number? This number, the one that I'm pointing with my pen there. This number. This number. It may be nothing, but it causes some things. Yeah, 0, guys. So when you have a product of factors and there's equal to 0, then you can apply, remember what I said, we can apply the 0. And I said to you, it's the 0 factor law. It can be applied, the 0 factor law. Let's go back, John. Look. X minus 3 into x plus 3 is equal to, look at this number. What is this number there? It's 0 again. So we can apply the 0 factor law. You take one bracket, equate it to 0, take the other, equate it to 0. Do you see that, guys? Do you see this? Hey, these people, I don't know if they feel me here. Look at this one. X minus 6 into x plus 1 is equal to 0. Then we apply the 0 factor law. This thing can only be applied. You remember, I even explained to you, if A times B is equal to, and I emphasized 0, then you can take the factor equal to 0, take the other factor equal to 0. We only do this, I repeat, only if there is, I want someone to say, if only there is on the other side 0. What if there's another number? Can we apply this thing? If there's another number? Can we? I want you to tell me, can we apply it if there's another number that's not 0? Can we do it? Mishi, you are the first person to answer correctly. No, Betty, no, Betty. Tando Felosi, no. Precious, no. Liam, no. RMJ, Mabs, no. Everybody's saying no. Let's go back to the question that we were looking at. X minus 8 into x plus 2 is equal to negative 16. What were we tempted to want to do? We wanted to take x minus 8 and equate it to negative 16, take x plus 2 and equate it to negative 16. Can we do that? Can we do that now that we have knowledge? The people perish because they lack knowledge. That's what they say. I'm sure there's a word in the Bible that says the people perish. Why? Because of lack of knowledge. They perish. Even in maths, people perish because they lack fundamental understanding of basic concepts, and then they perish. And they cry because level 2 and 3 is calling them and dragging them to the ground. It's like a hell of some sort, level 1 and 2 and 3, and even level 4, it's a hell. It's like demons, they are pulling you, destroying you. Right? So we cannot apply it. So people, whenever we have a product of factors and there's no 0 here, then that says that we need to get this thing first into standard form. How? Do you still remember this? Foil and then transpose. Hey, I hope you are hearing me here. Foil, then transpose, then like terms. You see, foil, transpose, like terms, foil, transpose, like terms, foil, transpose, like terms, foil, transpose, like terms, then standard form. You see this thing? But we only do this if there's another number where there's a product of factors on the left-hand side. Hey people, I hope you are hearing me. I'm dropping big things here. And I know for some of you, you have been captives to false notions in your head because you don't allow yourselves to really grasp certain things. I was looking through this other TikTok video and I saw this boy who got 100% for maths and 100% for science, and he was talking about how he jumped from 33% in maths and in a certain grade, and he got 100% when he completed grade 12. And I looked at that and I was like, if only people knew that when you begin to be serious about grasping the basics, you be serious about when something is being taught. You stop this mucking around and playing around. You try and be serious and grasp something. The minute you grasp it, you go and look for problems. You do them. You master that thing. You capture it. It becomes part of you. You own it. Then you're like, I've got it. then you consistently make sure that in every situation or scenario, when you arrive and do a particular problem that has to do with that thing, you don't leave it to any mistake. That's how it happens, man. Anyone can do that thing, because we all have the ability to do something like that if we work for it. Some of us work a little bit less because of our level of intelligence. Some of us have to grind and actually put in the effort, but we get there eventually. So please, people, work on these things. X minus 8 into x plus 2. So we FOI x times x, we know it's x squared. X times positive 2, positive times a positive is positive. 1 times 2 is 2, and then the x next door. Minus 8 times x, negative times a positive is negative. 8 times 1 is 8, and then the x next door. Negative 8 times positive, negative times a positive is negative. 8 times 2 is 16. Then we have a negative 16 on the other side, so we transpose it. It becomes plus 16 equal to 0. Halala. Foil transpose. Like terms. Hey, icon, foil transpose like terms. Woe unto him who would have taken x minus 8 equated to negative 16, x plus 2 equated to negative 16. They lack knowledge. We now have the knowledge, and we understand why we are doing what we are doing. So please, people, take down the notes and then make sure you internalize this thing. You cannot be someone who continues to make the same mistakes over and over again. It's a new year. We learn, we grow, we improve, we progress, we become better. 2x minus 8x, negative 6x. Hey, minus 16 plus 16 goes 0. Equal to 0. Standard form. Halala, standard form. We are there. We are there. How did you get here? We got here, guys. We got here. We got here eventually. We got here. Standard form. Now we are ready to do what? What is the next step after standard form? There's a quadratic expression on the left-hand side, so we can do what to it? We can factorize it. It can definitely be factored. Remember, the person who joins midway, all right, and is in grade 11, let's say perhaps, and is not in like a maybe finished, some people that join here are people that have finished grade 11 long time ago. So it's like this thing is bringing back memories of old times, maybe good times for some, maybe sore and painful times for others. So if you join in and you are in grade 11 and you are joining and you already get what's happening, it's because you know your work. It's as simple as that. Okay. Then after factors, zero factor law. X is equal to 0 or x minus 6 is equal to 0. Now the zero factor law can be applied. Why? Because there's a product of factors, but there's 0. Now we can do it. People, we can do it. We can do it. So x is equal to 0 is the first root, and x is equal to negative 6. When you transpose it, it becomes positive 6. We together, mostly. Everybody is with me. We are feeling it. We are chilling. The math is feeling us, and we are feeling it. We are feeling each other. There's a genuine crush that we are developing towards maths. There's a crush. It's genuine. We are discovering things about maths that we've never discovered before. It makes maths likable. He's attractive to us. It's like for the first time we're seeing maths' eyes. They look so sparkly. They are so good. Maths is a crush to us, and we're like, I want to get to know this maths guy. And the more you give yourself the time, and the more you spend time with maths, the more you fall deeply and deeply in love with maths, you will see something special happening. He won't help but want to give you good results, if you know what I mean. I hope you are feeling me here. You must feel me, people. It's very important to feel this thing. So here we know that is what. And you saw Ondinako is saying maths is the devil's subject. The reason why it's a devil's subject is because, let me tell you something. in any relationship, if you decide to spend less time with someone and you have an attitude towards that person, doesn't matter what they do. That person can go and buy you the car that you have wanted, but because you have this filthy attitude towards them, doesn't matter what they do is not attractive to you, so you hate them anyways. All right. So I understand Ondinako, the experience that he's had. I guess even if the crush goes and buys them a Beamer, they want a BMW, the crush buys you a BMW, but because you have this attitude and this feeling towards them, you don't like them. It's painful. I'm sorry, the Ondinako, your experience. But me, I'm trying to say, guys, have a good relationship. You will see things will be, hey, I don't want to say more. Let's hold it right there. But hopefully we're together. Here, we had to do FOIL and transpose so that we can get the standard form, factors, zero factor law, and then the roots. Last but not least, let's look at this question. X minus 5 into x plus 3 is equal to 0. I want us to check this one out. X minus 5 into x plus 3 is equal to 0. When you guys look at this, what do you want to do? Because there's something mathematically correct that you can do immediately with this question. Okay. Remember, in a standard way, yes, Gift, thank you so much. Even Queen Sokotela there, I think you are feeling, you guys are actually seeing what needs to be seen. Unam is also seeing it, yeah. So we are actually in this problem, we are at that stage where the factors are there and we are equaling things to 0. So we can immediately apply the what? The zero factor law. It's allowed. Unlike this one, x minus 8 into x plus 2 is equal to negative 60. We could not apply zero factor law here. That's why we had to first FOIL, transpose, get it to zero factor law. So yes, we can apply zero factor law immediately because on the other side we have 0. Unlike this one, where we did not have 0, so we couldn't apply negative 16 factor law because such does not exist. In fact, another number factor law does not exist. So therefore, we had to first FOIL, then transpose, get into standard form, then our factors, then our zero factor law, then our roots. So we are clearly at that stage where we can say x minus 5 is equal to 0 or x plus 3 is equal to 0. Then what do we do after that? We solve. X is equal to 5 is our first root, or x is equal to negative 3 is our last and final root. Okay. I am going to hold it right there for today. I'm going to hold it right there for today. Before I leave you, here is the maths challenge I have for you. I want you to solve for x for these 4 problems. The first one, just this one, x squared plus x is equal to 0. All right. The next one, 3x squared plus 6x minus 9 is equal to 0. The third one, x minus 3 into x minus 2 is equal to 0. And then the last one, x into x minus 16 is equal to 3 into 24 minus 5x, close bracket. And for all of these problems, people, I do not want you to use any other method besides the factorization method. No completing the square method yet, and no quadratic formula method yet. We are still looking at how to solve for x by factorizing a particular equation. So these 4 problems are what I want you guys to do for your game challenge. We call these game challenges. We don't call it homework. We call it game challenges. And you can do them. Then, at your own time and leisure, you can then explore other problems in a reliable textbook where there are questions on simply solving for x by factorization, because we have not yet stepped into the other types of methods. Okay, so I'll see you tomorrow at 9 p.m. again, my beautiful grade 11s. But before you leave, I want to ask some questions. These questions are very important for me. I want to ask this question. You remember the roots that we got for this particular equation, x squared minus 5x is equal to 6? We got these two roots. Can you see these roots? X is equal to 6 and x is equal to -1. I want to engage you in a conversation about, before you leave me, I want to engage you in a conversation about the nature of these roots. Inkangeleko, yabo, in Xhosa it's called inkangeleko yalamanani. What is the nature of these roots? 6 and -1. So answer the question. The first question I want to ask, are 6 and -1 real or non-real? Are these real numbers, 6 and -1, or are they non-real numbers? Is 6 and -1 real or non-real? Okay, so Pressure says real. Queen says real. Unam says real. Damien says real. I'm only asking about whether they are real or non-real. I've not asked anything else. Your ability to answer a question the way I have asked also, and to listen to what I'm asking and not answering something else, is a very key thing. Because even in mathematics, when you are given a specific question, it might say question 1, they'll say solve for x, but then they'll say to you, where x maybe is an element of other numbers. So you need to be mindful of what they're asking. Don't answer questions that are not asked. Be specific. Please, people, very key this thing in maths. So yes, you guys are 100% correct. 6 is a real number and -1 is a real number. So these roots, you see I'm using that word roots again. The roots are real. After solving this equation, I got two roots, the root that is 6 and the root that is -1. And these roots are what? They are real. Everybody here is saying they are real, and I am proud of you. Good job, my grade 11 learners. Next question. Are these roots rational or are they irrational? I repeat, are they rational or are they irrational? Vuzi says irrational, Pressure says so, Woman says so, Mama Shudu says so, Queen says so, K says so. Boitumelo says a different thing. Boitumelo says irrational. Okay. Boitumelo, you are the only one that is sticking out like a sore knife there. You are saying that it's irrational. Guys, do you still remember what a rational number is? A rational number is a number that can be written as a fraction, where the numerator of that fraction is an integer and the denominator is an integer. My grade 9 learners who have been joining my live sessions and my grade 10 learners will tell you that, because they've been learning that from the beginning when we started our lessons in December. So they know. Okay, I'll be disappointed if they didn't know. So I'm expecting you guys as grade 11 learners to know for sure. No problem, Boitumelo. That thing, it happens, the mistake. No problem. So we all agree that these numbers are rational. Amen. You guys today you are on fire. The last question I want to ask, are these roots 6 and -1, are they equal? Is 6 and -1 equal, or is 6 and -1 unequal roots? You tell me, equal or unequal? So Vizi says they are unequal. Vu3i says unequal as well. Busi Siwe says unequal. Lunati says so as well. Womashudu says so too. Luandle says so as well. Precious says so as well. Given says so too. Queen says so. Unarmed says so. Cartley says so. O'Kately, Gartley. User 319 says so. Kuchula says so. Nkwinika says so. Bontle says so. Boy to Malone says so as well. Okay, guys, you are 100% perfect. 6 and -1 are two numbers that are not equal. Like 6 is not equal to -1, is it? Is 6 and -1 the same? Are they the same? Look, if we are saying they are equal, we are saying 6 and -1 are equal numbers. I hope you are with me, KY. So 6 and -1 are unequal. They are not the same. Are you with me? So when I say are they equal or unequal, then you can clearly see that 6 and -1 are unequal. So if we were discussing together the nature of these roots for x squared minus 5x is equal to 6 after solving the equation, having solved the equation, we can clearly see that we can comment and say that the roots first and foremost are real, like we said. 2, the roots are also rational. And lastly, the roots are unequal. Hey, I hope people are feeling me here. Hope you can feel me, brothers and sisters. Hope you can feel me, brothers and sisters. Hope you can feel the fire of what I'm saying, brothers and sisters. Okay? Amen. Amen. We can discuss the nature of all of these roots. Okay? I'm sure you can see 3 and -3. You can discuss them. Real or unreal, equal or unequal, rational or irrational. Obviously, you can see the situation here. Real or unreal, and so forth, and so forth, and so forth. After solving the equation, we can talk about the nature, the nkangeleko of the roots. Right, guys, thank you so much. It was really good having you. It's officially 10:30. I have to leave the live for grade 11s. Thank you so much. It was great. You guys have been a great audience. It was phenomenal. Like, I wouldn't have asked for a better audience. I just want to say as well, thank you very much to Luandle. I think earlier on when the screen was a bit dark, Luandle was very characteristic in posturing ice cream cone there. I think 2 ice cream cones or 2. So thank you so much. Thank you so much, guys. Have a good one. We'll see each other tomorrow at what? At 9 p.m. again. Let me leave this live. I'll come back for grade 12 so that at least this video is recorded for the grade 11s, and then I'll post it on the YouTube channel, the same sections and segments. Please do the game challenge so that you can further solidify the concept that we've covered today and grasp it for yourself. Fall deeper and deeper in love with mathematics so that you and maths can be one. And the person who recommended that I need to be a life orientation teacher, no, guys, I'm in the right place. It is through maths that we will be able to also unravel and unlock life and teach life lessons. I like doing that with mathematics because there's a lot of things there and there that you can actually tie back into life. And remember, at the end of the day, maths is just an aspect of a subject you are doing at school, but you need to incorporate it and apply some of the things that are positive for your own personal life, because it is life that you need to live. And life is real, guys. Life is real. It's real and it's happening, and we obviously experience other aspects to our lives as well. Unfortunately, guys, I am not a physics inclined. I only do maths, so sorry. I'm not a Kevin, maths and science. Hey, that guy, I respect him. He's the one. And all these other amazing people that are doing phenomenal things that teach maths, physics, and then do life science as well. I respect those people. You guys should obviously please follow them and make sure that you subscribe and learn from them. You'll benefit a lot from them. I've heard many people attest how much they've been able to gather and learn, and even now some people are very far in the syllabus because those videos on YouTube and so forth and other platforms, they are assisting them to get further and further ahead, and get ahead of the game. So Good stuff. Guys, let me love and leave you. Let me just love and leave you so that I can get back here on the platform. Grade 12s, I'll be back just now. Just need to end the live so that I can restart it for you guys. Thank you. Thank you. Cheerio.